Hello and welcome to this video. Today we are selecting the optimal polymer for the base plate of a classic filter coffee machine, as you can see here above me. And we are using the polymer funnel method, this four-step process shown on the right side, starting with the first step, material selection factors. Funnel stage 1, material selection factors. So now we are collecting all the application requirements of this base plate and turn them into material properties. And there are certain questions which can help us in this assessment. And I call it the 6 whats. For example, what is the service environment of your part? What are the regulatory requirements? What type of load at which service temperature and time need to be fulfilled? What other things such as wear and friction, electrical properties such as CTI or electrical breakdown strength need to be considered? What is the preferred processing and fabrication method? And what are the economic and commercial considerations? And analyzing this base plate, I structured the requirement in 3 parts. The first part is functional requirements related to the part itself. The second is production and processing related requirements. And the third one is assembly related requirements. Back to the functional requirements related to the part. So the base plate serves also as a housing for electrical components inside, and we need to protect this electrical equipment against external mechanical impacts. And there are also standards like the IEC 62262, where certain tests need to be fulfilled. So therefore, design weaknesses need to be avoided and materials with high impact resistance are needed. And to stand also properly on the kitchen table, good mechanical stability needs to be ensured. And this to achieve stiffness, for example, we can use ribs. However, ribs have always the risk to increase also the surface defects because it's a visible part and also increase the tooling costs. So therefore, it's also better to have a plastic with high stiffness, so high elastic modulus, more engineering polymer. And also when we think of, we want to keep the coffee warm for a longer time, temperatures up to 110 degrees C can be easily reached. So we need also polymers with high continuous use temperatures, and also long heat aging durability are preferred. And also, since the coffee machine is used most of the time in a kitchen, it is exposed to all kind of fats, oils, soaps, cleaning agents, alcohols, fruits, vegetable acid. Additionally, we have water vapor, hot coffee spilling will touch this base plate, and therefore hydrolytic resistance is needed. So surface finish I also mentioned already. Optical quality are important, and we want high gloss parts and also scratch resistance, so to not damage the surface. And when we go now to the production and processing rating requirements, in this set of design, we need to use long screw bosses, and therefore we need polymers with good flow properties, and also we need to properly eject then these parts also. In addition, there should be no shrinkage warpage problems after the part was molded. And regarding the assembly related requirements, so in order to save some costs in assembling, snap fits should be used to easily connect and deconnect each other. And so we need a material with high elongation at break and flexural strength. Additionally, some self-tapping screws need to be used, and therefore so a more viscoelastic materials is needed. So these are now lots of requirements collected, and now we will turn this into our requirements sheets and into concrete values. So after we collected all these requirements, we turn them now into quantifiable data and added them to our what I call requirement worksheet. And you can see here the main criteria: maximum continuous use temperature of 110 degrees C I added here. I added the impact performance over the CHAPI tests, in notched and unnotched. I added Young's modulus, Flexur's modulus, tensile elongation, the chemical resistance, color change due to field exposure, hydrolytic resistance, and optical quality. And now this first step is done, and now we can continue with the second funnel step. Okay, funnel step 2, decision on thermoplastic or thermoset, and overview of the pre-selected grades and their commercial suppliers. So first decision is if we take the route of thermoplastic or thermoset. In our case, when we review the application requirements, impact optical processing, thermoplastic can fulfill these requirements in a better way compared to thermosets. The next decision branch in the thermoplastic route is to select whether we go with amorphous chemistry or semi-crystalline polymer chemistry. So in our case, both amorphous and semi-crystalline materials are feasible to fulfill these coffee-based requirements. And what we do now, we go into databases and material suppliers to look for suitable material candidates. There are some reliable databases such as the Campus or the OmNexus. And also myself, I created dashboards to support this step. I made a dynamic mechanical analysis dashboard, plastics pricing dashboard, chemical resistance of polymers, and also environmental sustainability dashboard. And when we screen out these databases with our requirements, we find several candidates. I found polycarbonate, SEN, styrene acrylonitrile resin, polyamide, then also polyester, so polybutylene terephthalate, PPT, polypropylene, and also polyketone. So when we look at unfilled polycarbonate, it can match the requirements. However, due to the long flow length, what we need, combined with ribs and the high viscosity of polycarbonate, filling of the part is harder. When we look at styrene acrylonitrile resin, it can be considered too. However, it will not fulfill the high continuous use temperature of 110 degrees C, because we have a SEN is maximum 85 degrees C. Polyamides, nylon 66, fulfills this 110 degrees C continuous use temperature. So with polyamide 66, we can go up to 120 degrees C. However, there are limitations of use due to the easy coloring when you're in contact with food. For example, parts molded in polyamide 66 easily take up the red spots when touched with red liquids, for example. This brings us to PPT, to the polyester. Hydrolytic resistant version of PPT can fulfill continuous use temperature, the optical aspects, the impact aspects too. So this is a suitable candidate we will follow. Also polypropylene and also polyketone. And this I summarized in this table, the grade and the commercial supplier, which we now then take to our third funnel step. Funnel step 3, selection discussion with the worksheet, what I call the qualitative matrix analysis, and also the results of this matrix analysis. So we reached now the core of the selection funnel, the qualitative matrix analysis. It is a detailed selection discussion with a worksheet. It ranks all the pre-selected polymers from before, so the PPT, the polypropylene, and the polyketone, on how good each of these polymers fulfills the requirement. Additionally, the requirements are ranked according to their importance too. And it's always a ranking from 0 to 5, and also with the requirements fulfillment from 0 to 5. So 5 is the best, and 0 or 1 is the worst. How to start this qualitative matrix analysis? So I created an online tool for this, what I call the Polymer Material Selector. I will link it also below. and I can also provide you with a simple Excel version of it. And the outcome of this qualitative matrix analysis is presented here. So when you look, all three candidates are really close together. So PPT with 182 points is in the lead, followed by polypropylene with 180 and polyketone with 182. So this means we will, in the final step 4, we will investigate all three of these polymers and test all these three, and to make then the final decision which of these three are the most suitable candidate. Final step 4, testing and selection of the final material and the vendor. So the last step is as important as the steps before, because now we need to find out in the real part if we can fulfill all the requirements. And on the one hand, we have standard tests, standard safety tests according to IEC and CEE, what you already mentioned in the beginning, like the spring hammer tests, which needs to be fulfilled. But there are also other tests like long-term testing. So important is, in this phase, you create prototype tools and make real parts, really this coffee base spray, and then start testing it in as a single part, but also then as an assembled part. And for example, let's take the long-term endurance testing. This is done to simulate 10 years of lifetime. And the advantage is such long-term tests allow us to assess things such as deformation over time, warpage, coloring, decoloring, coloring changes, material change, and also embrittlement of the material. And when we test now PPT, PP, and polyketone, as a result, PPT performed well. The other two performed well too. However, there's one big difference. The design of the part needs to be adapted to compensate for higher shrinkage and warpage values of polypropylene especially. So this base plate of the coffee machine gets more complex by using polypropylene, and you have to adapt the design in order to have the same part quality as with PPT, because PPT is still an engineering polymer, has other values compared to polypropylene. So this is a bit challenging to achieve the same part performance with polypropylene, or in general with a material which has a lower overall performance profile. However, with good training in part design and part optimization, what you can do now also in this phase, materials such as PP and polyketone are replacing more and more more expensive engineering polymers such as PPT and polyamide. So it's really possible also in our case. Okay, and this brings me also to the conclusion of the final step 4 and of the all-over material selection. So PPT can be used for the premium segment of these filter coffee machines, and polypropylene as well as polyketone can play an important role in the more mass market applications, which is more price sensitive. So for the more simpler machines and so on. So you can really split it. You can serve different markets with PPT and with PP and polyketone, and all these three materials I mentioned before, the grades can be used for this part. Okay, I would like to thank you for watching, and if you have not yet subscribed, please subscribe, give me a like if you enjoy this video, and I'm looking forward to the next selection example. Bye.